What up, it's your boy C Rizzy coming at you with this second video of the year, Unit 1, Lesson 2, Points, Lines, and Planes. I do not have a joke for the day. Hopefully Mrs. Rodson can hit me one before the end of this video, but our essential question for this video is, what in geometry is assumed to be true, and what has to be proven? And our objective of today is to understand basic terms and postulates in geometry. So here's your answer to that, or your essential understanding. Geometry is a mathematical system built on accepted facts, basic terms, and definitions. In geometry, some words are undefined. These terms are the basic ideas that you use to build the definitions of all other figures in geometry. So in geometry, you have the building blocks, things that are undefined, followed by postulates and axioms, which then lead to theorems. So without these building blocks, we couldn't get to our postulates and we could not get to our theorems. So let's talk about things that are undefined and are just accepted to be fact. For instance, a point. A point indicates a location and has no size. So one thing you need to pay attention to on this slide is not only the definition, but the notation. Okay? Notation of what a point is. That's always what a point is. Okay? A line is represented by a straight path that extends in two opposite directions without end and has no thickness. A line contains infinitely many points. So a line is always defined with at least, or at most or at least, 2 points. So here is the notation for a line. So in this problem you have line A, B. So if you ever see this little notation above 2 letters, this stands for line, and it's read as line AB. Okay? As it said, a line continues on to infinity in both directions. A plane is represented by a flat surface that extends without end and has no thickness. A plane contains infinitely many lines. So a plane has to be identified by at least 3 points. Okay? If you do not have 3 points, it cannot be a plane. But because of these 3 points, I can have an infinite amount of lines that go through my plane. A segment. A segment is part of a line that consists of 2 endpoints and all points between them. So the difference between a line and a line segment is a line segment has a beginning and an end. Okay, here this line segment, it starts at A and ends at B. Okay, a line segment is the same thing as it looks the same as a line, except you don't put the arrows, and this is said as line segment AB. This notation is very important. A ray is part of a line that consists of 1 endpoint and all points of a line and all the points of the line on one side of the endpoint. So a ray, think about the ray of a sun. Okay, it has a starting point and then it goes on for infinity. Okay, why they call them sun rays? Well, it's because where does light come from? Light comes from our sun. Hello. Okay, and the rays and the light have a source, the source being the sun or the endpoint A, and continue on forever in another direction B. Okay, the ray notation looks like a line, looks like a ray, and it's said as ray AB. Opposite rays are 2 rays that share the same endpoint and form a line. So how we label a ray is by its endpoint. So let's say I had a ray A, B. All right, if my rays are opposite, then my ray needs to start at A as well. So opposite rays would be ray AB and ray AC. If 2 rays do not start with the same letter, then they cannot be considered opposite rays. Okay, this is important to know. A postulate or axiom is an accepted statement of fact. Postulates, like undefined terms, are the building blocks of the logical system in geometry. So here's our first set of postulates. Through any 2 points, there's exactly 1 line. So if you put 2 points on a piece of paper, any 2 points you want. So I'll give you an example as soon as I find my pen. If I put any 2 points anywhere on the bottom of this screen, there can only exist 1 line that goes through both of these. Okay, and this is the 1 line. I'm going to call it X, Y. Okay, so this is line X, Y. Another postulate is that if two distinct lines intersect, there can only be but one intersection point. Okay, so there are two lines that intersect with one another, and there can only be one point that touches both of those lines, and that point would be point C. If two distinct planes intersect, then they intersect in exactly one line. So here you have two planes. Okay, they essentially just look like two rectangles, and where they intersect is at a line. And through any three non-collinear points, non-collinear means not on the same line. It's important to know what non-collinear means. There is exactly one plane. So if points Q, R, S are non-collinear, meaning they are not on the same line, then plane P is the only plane that can contain them. Okay, so let's practice. So name a point that is coplanar with points P, L, and K. So coplanar means same plane. So in this picture we have a cube. Each face of the cube represents its own plane. So if I have P, L, and K, well then obviously I'm talking about this box at the bottom. So that other point would be point O, or otherwise written as the notation way. This is by notation. Name a plane that contains point I, J, and O. So I'm going to do the same thing again here. I, J, and O. This is interesting. I have I, J, and O, but they're not on the same face. So what also could happen is you have something called the diagonal plane. So I could actually connect these points like this, and now I have a plane. These are three non-collinear points, which is what defines a plane. And I have this other point P that is now part of this diagonal plane, this plane that's actually cutting through the cube. Name all the non-coplanar points with plane MPN. So what does non-coplanar mean? Means not the same plane. So here's M, P, and N. So it's got coplanar points of O, and MP and N do not have are not part of the diagonal plane. So it is only this plane that it's a part of. So every other point that's not highlighted are the points that are non-coplanar. So points L, K, J, and I are non-coplanar. Okay, lastly, where do plane MPL, plane JKI, and plane POK intersect? So the first thing I'm going to do is I'm going to highlight the points in the plane. So M, PL, J, KI, and POK. So I've got this plane, and this bottom plane. 3 planes. And well, I know that there is one point that connects all of them. So I have M, P, L, I is one plane. I have J, K, I, and L as another. And lastly, P, O, K, and L as the last plane. And what do all these planes have in common? But the letter L. So L must be the place where all these points intersect.